Hi, welcome. Now I am going to show you how to solve a allocation problem using a Hungarian method in Excel. Okay, I am going to solve this problem using solver. Okay, what I have here is that 4 persons and 4 jobs, and each person to be allocated to one of these jobs. Okay, similarly these 4 jobs also must be allocated to one of these 4 people. Okay, a person can hold only one job. Similarly, a job can be allocated to only one person. Okay, this is the cost matrix, and you have for each person how much is the amount incurred as a cost when allocating that person to that job. Okay, for example, here the first person one having $205 for allocating him to job 1. Okay, this is the cost incurred, or you can say this is the expense for allocating this person to the job, or this is the amount we need to pay to the person 1 for doing the job 1, or this is the quotation we got it from the person 1 as a supplier to allocate this job to him, or a contractor. Okay, and so on. So similarly for this is the amount $333 to be allocated to is the cost for the person 1 to be allocated to job 4. Okay, this is the overall cost matrix for each person if he is allocated to a particular job. Okay, now how can we solve this problem, this allocation problem? Okay, for any problem you want to solve it, this lies in the formulation of that problem in Excel worksheet properly. Okay, so you must know how to formulate the problem properly in the Excel worksheet. Then you can use that cells, the variable subjective function cells in Excel solver. Okay, then it is very easy for while you put your constraints and objective function in solver to solve it. Okay, I have a format here. So first of all, to solve this problem you need to know the variables. Okay, so I put I'm doing the variables part here, and this part is the constraints. Okay, so what is the variables? Variables is for each person needs to be allocated to a particular job. So either he can be allocated, not allocated. Allocated is 1 and not allocated is 0. For example, the person 1 is allocated to job 1, then he is 1. Okay, if he is allocated to job 1, he cannot be allocated to job 2, job 3 and job 4. Okay, similarly the job 1 cannot have other people also, person 2, person 3 and person 4. Okay, so this is the way these cells are going to work like variables. Instead of we put this is x11, x12, x13 and x14. Okay, or P1J1, P1J2, P1J3, P1J4. we just use the cell names. Okay, these are all the cells. We are going to use it for solver to solve it. Okay, so this is J3. J3 is nothing but person 1. J2 is nothing but person 1 allocated to job 1. This is K2. Okay, K2 is nothing but person 1 allocated to job 2. Okay, so you no need to worry about the cell names. Okay, we are going to just select it in the solver, that's it. Okay, this range. Similarly for if I just put a person 2 is allocated to job 2, then others cannot have that job, and that person cannot have other jobs, and the job 2 also cannot have other people. Okay, something like this. So I put a diagonally 1 1 1 as a initial solution. Okay, this could be anything, but for understanding purpose I put this. Okay, so these cells are having the variables. Now currently this P1 J1 having 1, the other cells these are all having zeros. Okay, or you can just put zeros also. Okay, now this is the variables actually. Okay, so and now what we have is the the constraints. How to write the constraints? One of the constraint is these cells can have 0 and 1s, they are binary. Okay, that is one of the constraint. Okay, what is the other constraints? Each row can have only 1, the others are 0. Correct? A person is allocated to any of the jobs. Okay, and if he is allocated to one job, the other jobs must be 0. So the constraint is these row, if you add together, it will give only 1. Okay, so this is person's constraint. Person 1's constraint is, if we add his allocation to all 4 jobs, we must add, we will get only 1, because he can be allocated to only one job. Okay, so that constraint, what I am going to do is I am putting left hand side and right hand side of the constraint. Okay, now I split each constraint into 2 parts. One is left hand side and right hand side. Okay, so for the person 1, if I add all these values, it's supposed to be equal to 1. So sum of all these values, okay, is equal to, right hand side is 1. Okay, the sum of all these values equal to right hand side is 1. Okay, similarly each person. Okay, this is person constraints. Okay, sum of all these values, okay, supposed to be equal to 1, constant 1. Okay, similarly for person 3 and 4, the right hand side is also equal to 1, 1, 1. Okay, similarly for left hand side and right hand side for each job, sum of a job allocated to any person, job can be allocated to only one person. So if I had the sum of these columns also equal to 1, right? So sum of this is job constraints. Okay, this sum, each column sum equal to right hand side is 1. Okay, okay, so similarly for job 2, right hand side is also equal to 1, sum of job 3 equal to 1, sum of job 4 equal to 1. Okay, this is the variables. These together give you a constraint. So what we have is 8 constraints, and one more constraint is all these job variables are binary. Okay, and this constraints is left hand side also equal to 1. Okay, now objective function. Okay, the objective function. Now objective function is nothing but இது வேணாம்ப்பா எனக்கு. கூப்பிடலப்பா உன்னை, நீ போய் எழுதி முடிப்பா முதல்ல. Now the objective function. Objective function is Okay, now the objective function. Objective function is each variable here, if you allocate with the cost value, okay, the total overall cost must be minimum. So I want to minimize, okay, the objective function is I want to minimize, or put it here, minimize, okay, but minimize what? Minimize what? If I select a job 1 with the variable here, okay, the products of each variable here, the variables can be 0 and 1s. If it is selected, it will become 1. If it is not selected, it is 0. So if I multiply the cost matrix with each variable, okay, the overall sum must be minimized. Okay, if I multiply each cost with whether it is allocated or not, okay, if it is allocated, then the cost must be present because the value is 1. If it is not allocated, the cost won't be present because the value is 0. Okay, if you multiply each element of cost matrix into every corresponding variable here, the overall sum must be minimized. Okay, but before that, how can we multiply each variable with each element here, each cost with each variable here? Okay, for that we have a sum product function. You may be knowing the sum product function already. We have two arrays, array 1 and array 2, okay. So if you have a set of numbers 1, 2, 3, and if you have a set of numbers for 3 numbers for array 2, the sum product, what it will do, sum product function of array 1 comma array 2 will product the corresponding elements and give the sum, okay, sum of the products. Okay, 32. You see here, this first element into array 2 first element, similarly array 1 second element into array 2 second element, similarly array 1 first element into array 2, array 1 third element into array 2 third element. If you do the sum, you can see the same answer, 32, right? So the sum of product function will give the multiplication of the array 1 into multiplication of the array 2. Okay, if you pass two arrays, it can be a rectangular array also, not necessary a column wise. So I am passing the first array, sum product cost matrix comma the variables matrix. So I want to, each element need to be multiplied, corresponding elements need to be multiplied, and finally give the sum. You see 971 is nothing but because in the variables we selected person 1 job 1, so this is selected, and similarly these are all 0 when we multiply with the variable 0, value 0. This is also selected, the diagonal ones are selected. If you see the sum, you will see you can see the sum. You see 971. You see in the status bar 971. So only when you this sum will change according to when you change the person and job matrix, okay, the variables. Okay, I hope this is clear. Okay, so now what we are doing here is that now we are going to minimize this value, okay, according to the variables this. Okay, now what I am going to do, I am going to use the solver. We are set everything ready for solver, where you can find the solver data. Okay, in the data you can see a group here, analyze, but because we don't install solver yet, so it is not there. Okay, how can I install the solver? Go to file, options, then add-ins. You can see the solver add-in is there. Okay, go to Excel add-ins, go, then you can see all available add-ins. Just tick solver add-in. Okay, now it is added in the data. You can see here the solver analyze. Okay, in the data option you have analyze and solver. How can you install the solver? Go to option, go to add-ins, Excel add-ins, check it. Okay, now after that you go data, you're going to use the solver. Objective cell must be single cell on the active sheet. What happens here is that I already used the solver, so it is because of previous values is giving this message. You no need to worry, this reset all. Okay, now you again open it, solver. Okay, for your case you may not be getting the message. Set the objective is nothing but this cell. Okay, so this is the cell we want to minimize. What we want to minimize, set objective is this cell. What do you want to minimize? What do you want to do? Minimize, not maximize, minimize. Now the changing variable cells, very simple, it's here. Okay, now you want to add the constraints. What you need to do is you can add one constraint here. This is left hand side constraint and this is right hand side of the person one constraint. You can, this is equal to constraint this. Okay, something like this. Okay, add again, add this one equal to this left hand side and right hand side of person to constraint, add, and so on. Instead of adding one by one, okay, what you can do, this one also you can add it in one stitch as a array. How can you add left hand side of all the person constraints must be equal to right hand side of all the person's constraints. Okay, okay, similarly add left hand side of all the jobs constraints equal to right hand side of all the job constraints. Okay, add. Now we added two constraints. Now one more constraint is there, that is add all the variables must be binary, 0 or 1s. Okay, there is a option here, cell reference option here, binary. Okay, add. You can see we added the three constraints. Okay, one is the first this is all are binary, this is all job constraints. Each job constraint all are, this is j's are these constraints, person constraints. All this itself is 4 constraints actually. We put it as a array. Then make unconstrained variable non-negative. Okay, the variables are non-negative, and we are going to use the simplex LP. Okay, you can see here, select GRG non-linear engine for solver problems that are smooth and non-linear. GRG non-linear. Select the LP simplex engine for linear solver problems. This is linear solver. Okay, and select the evolutionary engine for solver problems that are non-smooth, like the salesman problem. Okay, so what we are doing, simplex LP. You also have option for simplex LP to what is your constraint precision, and how many times, how many iterations you want to give, or maximum time what you want to give for algorithm to look for the solution, all the stuff. Okay, for me it is for this sum the default values are enough. Okay, now what I'm going to do is, now everything is fine, we are going to solve the problem. Okay, solve. Wow, so fast it is giving the solution. Okay, now you can see the solver found a solution. All constraints are optimally, conditions are satisfied. You want the outline reports, you can give reports also. Okay, you can see. Okay, now you can have a answer report. What is the value, what is the options, and you selected for LP, and what are the variable cells, and what it is, integer and binary, and what is the original value you have given, what is the final value, and so on, constraints and so on. Everything is there in the report. Okay, we will go and see the solution. The solution what we have is, the person 1 has to be assigned to job 4. Our optimal solution, our initial solution we given in the diagonal order, but in the optimal solution it is giving, it changes the value giving, because it's variables, it's changed value, and it put the person 1 to job 1. Person 2 and 3 remains the same, but person 4 is into job 1. Okay, now the value is, minimum is 804. Okay, so the cost involved is, you can see this job 4, the solution is this. Okay, I give a color, this is the solution. Okay, so what you have is the amount, the status bar, you can see 804. Okay, this is the minimum amount you can incur by allocating these people. Okay, if you are not using the problem, what is the risk of having the maximum amount? We can do for the fun part of it, we will do the maximus and see what could be the maximum solution. Okay, go to solver, just to maximize. Okay, you can see $1,774 is double the amount. If you are not doing this problem, if this decision making allocation problem is not available, there is a risk of you are selecting the maximum amount. If you select the same thing, the maximum amount, then what will happen? Job person 1 will be job 3, and person 2 is this all red. Okay, I'll put a red. If you give this solution, okay, there is a risk of selecting this solution. You will have about $1,774. Okay, just we will keep it here, $1,774. Okay, we'll go to our initial solution minimum. the same thing, go to solver, minimize. This is $804. So how much is more? $804, 970, more than twice you may be paying it. Okay, this is the beauty of these allocation problems of operational research. It minimizes the risk. Okay, so I hope you understand my way of doing the formulating the problem and using the solver. And also this math fun is really fun for us. And if you like my videos, please subscribe to my channel, and God bless you.